Hello everyone, hope you are good. Stay home and stay safe. This is your teacher of mathematics, Teacher Innocent, and I want us to learn about fractions. What do you know about a fraction? I'm very sure that from your primary classes, P4, P3, P5, P6, we have been talking about a fraction. And you know what a fraction means? To remind you, a fraction is simply part of a whole. Take an example, 1 out of 2. This simply means 1 part out of 2 parts. If I have a fraction like 4 out of 9, it simply means 4 parts out of 9 parts. So you know what a fraction means. It's just part of a whole. Let's have a look at this. I have my whole. This is a whole. Have a look at it. It is one whole. I can divide this whole into 2 equal parts. This is one part and this is another part. So this is one part out of 2 parts. Even this is one part out of 2 parts. If I have a whole, I divide it into 2 equal parts. This is one part out of the 2 parts, this part here. And this is also one part out of the 2 parts. So these 2 parts, when they combine, they make a whole. And that is what we call a fraction. Let me show you this as well. Let me show you this as well. Have a look at this. These parts combine to form a whole. This is my whole. You have a look at this. This is a whole. And this whole can be divided into 3 equal parts. For example, this is one part. This is the second part, and this is the third part. So there are 3 parts from this one whole. So this is 1 out of 3. Even this is 1 out of 3. Even this is 1 out of 3. They all combine to form a whole. If I combine them, they form a whole. So this is what we call a fraction. When I combine them, they form one whole. And this is now my whole. So this now becomes 3 parts out of 3 parts, making a whole. So that is what we call a fraction. So at this time, let us apply fractions in our real life. Let us have our example. Application of fractions. Number 1. Our example number 1. In a class, 2 out of 3 are girls, and the rest are boys. If there are 30 boys in the class, how many children are in the class altogether? When you are reading the question, you first read it once. Then when you come for the second time, you are analyzing what the question is all about. Remember, these are words. So we must read the words, interpret them, and we work it out. In a class, 2 out of 3 are girls, meaning that the fraction that represents the number of girls in the class is 2 out of 3. And the rest are boys. That means we don't have the fraction that represents the boys. But very simple. What will be the fraction to represent the boys? Remember, if I have a whole if I have a whole, and this one is going to represent the whole class, the total number of children in the class. 2 out of 3 are girls, meaning that the 3 parts is the total. So this one is divided into 3 parts. Then the girls, the fraction for girls is 2 out of 3. So when I shade the 2 parts of these 3 parts, so these 2 out of 3 is for girls. That means that the remaining part, which is 1, this is 1, out of the 3 parts will be for boys. So 2 out of 3 is for girls, and then 1 out of 3 is for boys. That is the remaining fraction. So the remaining fraction for boys is 1 out of 3. So this is a simple diagram that can help us to get the fraction for boys. But without using a diagram, I can also work out how am I going to get the fraction for boys. That the whole class is having 3 out of 3 minus the fraction for girls. That if I get the whole class, the fraction that represents the whole class, minus the fraction of girls, which is 2 out of 3, I will get the fraction of boys. What could be my LCM? The denominators are the same. Very simple. The denominators. Therefore, my LCM is 3. The LCM of the denominators is 3. And when the denominators are the same, I simply work out the numerators. 3 minus 2. So the fraction for boys is 3 minus 2. This is 1 out of 3. You see? 1 out of 3 is the fraction for boys. We got the question. If there are 30 boys in the class, you can see now, the number of boys in the class is given. So we have to use the number of boys in the class to get the total number of children. So if 1 out of 3, if this part represents the 30 boys, now what about the 3 parts? I repeat this. If the one part, the one we have said that 1 part out of 3 parts represents the boys. If 1 part represents 30 boys, what about the 3 parts? That is something we have to think about. And therefore we say that, come here, we are looking for the total number of children in the class. Total number of children in the class. So we say that 1 part, we remember we are using the fraction for boys. 1 part, this 1 part represents the 30 boys. Why do we say that 1 part represents the 30 boys? Because the fraction for boys is 1 out of 3. So the 1 part represents the 30 boys. What about the total? How many parts represent the total? If you have a look at our diagram, 1, 2, 3. The 3 parts represent the total number of children in the class. So 3 parts represent, we shall have 30 for 1 part times the 3 parts. And here comes simple mathematics, boys and girls. If you have 30 times 3, have a look. 3 times 0 is 0. 3 times 3 is 9. So 30 times 3 is 90. Oh, somebody can say, there is simple mathematics here, simple computation, that 30 times 3, I can get 3 times 3, which is a 9, and I add a 0. So we will get 90 children. So 90 children is the total number of children in the class. As simple as this. Boys and girls, for point of emphasis, if the fraction of girls is 2 out of 3, and the boys, the fraction representing the number of boys is 1 out of 3, and the question is giving us the number of boys in the class, we must use the fraction for boys to help us get the total number of children in the class. And that is the reason as why we had to look for the fraction representing the number of boys. And after getting it as 1 out of 3, so we are saying that this one part represents the 30 boys. What about the 3 parts? So the 3 parts will represent the total number of children in the class. As you're working out fractions, you think about that. Which parts represent the given quantity, the given number in the question? I thank you so much. As we are going to example number 2. Thank you so much. Welcome. This is number 2. Let us have example 2. Tom, Richard and Tracy contributed some money to start a business. Tom paid 3 out of 10 of the cost. So you must think about that. The fraction Tom paid is 3 out of 10 of the cost. And Richard contributed 5 out of 10 of the cost. So as you're reading a question, you are looking at someone and the corresponding fraction, or you are looking at this fraction and you ask yourself, what is this fraction for? When you look at 3 out of 10, what does it represent? When you look at 5 out of 10, what does it represent? That is something you must be very careful with when you're talking about fractions. But I know you very well, children. You can read the question very well, interpret it, and answer. So we are interpreting these words. We are applying fractions in our real life. And then we see how can we calculate such numbers. Thank you so much. Let us now attempt part 1. What fraction did Tracy contribute? Look at solution for number 1. Tom, Richard and Tracy contributed some money to start a business. Tom paid 3 out of 10 of the cost. Tom. So the fraction for Tom, this one is 3 out of 10. Tom contributed 3 out of 10. And Richard contributed 5 out of 10 of the cost. So Richard contributed 5 out of 10. So we are having the fraction for Tom, we are having the fraction for Richard, but remember, there are 3 people who contributed for the business. We know the fraction for Tom, we know the fraction for Richard, but we don't know the fraction for Tracy. So it is very important. What fraction did Tracy contribute? We need to know what is the fraction for Tracy. We don't know the fraction for Tracy. So having the fraction for Tom, the fraction for Richard, and the fraction for Tracy, and now we are looking for the fraction for Tracy, we can easily look for it. How can we look at it? Look at this. If I have a whole representing the whole business, the total contribution of the 3 people, Tom, Richard, and Tracy. Tom, 3 out of 10. Richard, 5 out of 10. Meaning that the total parts are 10. So I will divide this one into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. This is 9. And this is 10. So Tom has 3 parts out of the 10 parts. So this is Tom. This is Tom with 3 out of 10. Are we together there? Good. Then we have Richard. Richard has 5 out of 10. 1, 2, 3, 4, 5. So from here up to here is for Richard. I think that. So this one is Richard. 5 out of 10. So that means out of 10, they are the remaining parts that represents Tracy's contribution. Are we together here? Have a look at this. The 3 parts for Tom. The 5 parts for Richard. And meaning that the remaining parts are for Tracy. So children, how many parts are remaining? Have a look at this. 1, 2. So 2 out of 10 parts remained. Very simple. That means the parts for Tracy, they are 2 out of 10. This is a simple diagram to represent the contributions of the 3 people. Now let us work it out. We are going to look for the total fraction of Tom and Richard. Total fraction of Tom and Richard, because we know them. The total fraction of Tom and Richard. Tom is 3 out of 10 plus, what is the fraction for Richard? Very good, 5 out of 10. We are very lucky that the denominators are the same. So our LCM of the denominators is 10. And when the denominators are the same, you simply add the numerators. 3 plus 5. So what is 3 plus 5? I will have 8 out of the total, which is 10. This means that the total fraction of Tom and Richard is 8 out of 10. After getting the total fraction of Tom and Richard, we can look for the fraction of Tracy. It means that our 10 parts are the total. So we shall have 10 out of 10 minus. We are now looking for the fraction. We are looking for fraction for Tracy. Fraction for Tracy. We shall have 10 out of 10 minus the total fraction of Tom and Richard, which is 8 out of 10. We got it from here. After adding 3 out of 10 plus 5 out of 10, we get 8 out of 10. So when we get 10 out of 10 minus the fraction of Tom and Richard, which is 8 out of 10, we shall remain with the fraction of Tracy. So this is, when we are working out fractions with the same denominators, children, this is 10. That is our LCM of the denominators. Then this is 10 minus 8, because if the denominators are the same, you simply subtract the numerators. And therefore, what is 10 minus 8? Oh, very good. 2 out of 10. So 2 out of 10 is the fraction for Tracy. And we have now finished our part 1. Now let us attempt part 2. If Tracy contributed 30,000 shillings, the amount of money we have is that amount of money contributed by Tracy. And therefore, we are using Tracy to look for the total contribution. So what are the parts representing Tracy's contribution? Look, 2 parts out of 10 parts represents Tracy's contribution. So the 2 parts, of course we are talking about Roman numeral 2, the total contribution. So we are using Tracy 2 parts to represent 30,000 shillings. Are we together there? What about 1 part? What about 1 part? 1 part represents 30,000 shillings divided by the 2 parts, divided by 2. There is simple mathematics here. How can we divide 30,000 by 2? We can see that 30 divided by 2. How many times can 2 go into 30? Think about that. Think about that. Who can tell me the answer? Think about that. 30 divided by 2. So this is 1 and this is 15. So you'll get 15,000. So that means one part represents 15,000. Are we together there? So if one part represents 15,000, now we are supposed to have the total contribution. We are looking for the total contribution, and therefore the total contribution, have a look at this. The two parts represent 30,000. One part represents 15,000. But the total contribution is represented by the 10 parts. That means that if one part is 15,000 shillings, what about 10 parts? Remember, the 10 parts are the parts for Tom, Richard, and Tracy, the total contribution. And therefore, if 10 parts is the total contribution, that means that 10 parts will represent 15,000 shillings, which is one part, times 10. We are going to apply simple mathematics here. When you have 15 times 10, when you have let us have the following examples. When you have 3 times 10, what is the answer? Very good. This is 30. 3 times 1 is 3. You just add a 0. When you have 7 times 100, 7 times 100, what do you get? 700. So the same applies to this. 15 times 10, we get 15 times 1, and we get the answer as 15. Then we count the zeros. 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, you put a comma there. So you'll get 150,000 shillings. That means that their total contribution, Tom, Richard, and Tracy, is 15,000 shillings. Boys and girls, I want you to think about this. That to get the total contribution, we must use the fraction for Tracy, because Tracy's amount of money is known. So we shall use the amount of money Tracy contributed to look for the total contribution, meaning that we use the fraction for Tracy. That's why we are looking for it. It is very important. After looking at example 1 and example 2, we can now attempt the activity given. We are having numbers to do following example 1 and example 2. Thank you so much. I hope you will pass all the exercise given, all the numbers given in the activity. We meet in the next lesson. Thank you so much. Now let us try out this number and we see how we can operate these fractions. Fred, John, and Trevor owned a business. Fred's shares were 2 out of 11 of the total share capital. John's shares were 5 out of 11 of the total shares. Part A. What fraction of the shares did Trevor own? Then part B. If Trevor's shares were 56,000 shillings, what was their total share capital? So we have to follow the examples and we attempt this question. Thank you so much.